Brazil using satellite remote sensing to monitor soybeans. What exactly is AI doing here?
Behind this is mainly cloud-based AI computing modules. They process massive batches of images, understand them, generate prescriptions.
In smart lawnmowers, the AI computing module is the on-site co-pilot on the lawn, linking seeing boundaries and obstacles, understanding grass status.
When seeing, driving steady, cutting accurately, are all done on-site and continuously self-optimized, the smart lawnmower isn't just automated, it's a thoughtful household partner.
Welcome to IoT Simple Bites. I'm Mia. David, on my way to the studio, I was scrolling through short videos and saw this drone in a farm field. Land, print out a prescription map, then take off again for variable fertilization. The whole scene was like pouring data straight into the soil. It made me wonder, beyond stuff like vending machines and self-checkout scales in malls, is AI already getting serious in those scenes that feel a bit further from daily life?
Great observation. Last time we talked about retail, which is close to everyday life, but whether AI is useful is often proven in those places that don't look as fancy.
Let's switch gears today then. Let's start with agriculture first.
Same rule as always. You throw out the questions, I break down the scenes.
No problem. You know I always do my homework.
Yeah, let's dive in then.
All right, here we go. Right now, many agricultural powerhouses around the world are using AI to boost productivity. Let's start with the looking at the ground from the sky perspective. Brazil using satellite remote sensing to monitor soybeans. David, what exactly is AI doing here?
Think of it like taking a photo with your phone. The original image is live, filters are enhancement, and face recognition is understanding. Satellite imagery is like a super wide-angle camera, and AI turns that original into a readable health report, then turns the report into an actionable to-do list.
Wow, that sounds really challenging.
Behind this is mainly cloud-based AI computing modules. They process massive batches of images, understand them, generate prescriptions, like a super photo editor plus medical report engine.
But you know, Brazil's rainy season is cloudy, like a blanket covering everything. How do they see through that?
All credit goes to AI. It lets different eyes take turns. On sunny days, they use optical satellites like high-def cameras, and on cloudy days, radar satellites, like fog-penetrating X-rays. The cloud-based AI computing modules stitch and calibrate these two types of images.
Kind of like switching between satellite view and regular view in navigation, right?
But it automatically identifies cloud shadows, aligns ground features, corrects geometric errors, making sure you can see the real changes in the fields, rain or shine.
Once they see it, how do they know if the crops are growing well?
They translate color and light into vitality scores. AI uses indices. Think of them as leaf health values and nutrient sensitivity values to create heat maps of health. The index calculations, anomaly zoning, and time series analysis.
So all these are running on cloud-based AI computing modules as well?
Yeah, like a doctor's imaging system. Not just giving scores, but breaking down why it's low into 3 clues: water, nutrients, pests and diseases, reducing misjudgments.
So, how do farmers actually use this? Let's not just stop at pretty pictures.
Well, actually AI turns pretty pictures into useful pictures, prescription maps. The cloud-based AI computing modules fuse imagery, weather, soil, and historical yields to automatically generate machine-executable task packages. Spray more in Area A, less in Area B, observe first in Area C, plus confidence levels and priorities. Machines follow the prescription, and differential management hits the ground.
Could it make a wrong judgment? Like, when the reflection after rain is really bright, it gets mistaken for good growth.
AI does filter out the fake, keep the real. Cloud computing modules do cloud shadow detection, post-rain highlight correction, bare soil separation, and radar optical fusion verification. Multiple models working together to weed out as much illusion as possible. It's like a fitness tracker filters out the shaking from taking the elevator so it doesn't mistake that for steps.
That sounds way more believable. Is there a growth curve? Like how parents measure their kids' height?
Yeah, it's called a growth diary. AI tech maintains a time series model for each plot. Regreening, flowering, grain filling, each has its own curve shape. When the current season's curve deviates from your field's normal, it pushes notifications to go check specific patches, faster and more objective than humans patrolling the fields every day.
Can farmers find that tiny problem area in the field?
Yep, phone maps navigate directly to which row, which plant. Field gateways usually have a lightweight AI computing module that does offline prompts, so even in weak network conditions, it can guide. That forms a loop, from sky to ground, from ground back to correct the sky.
Well, I was thinking, using satellites must not be cheap. Is this really worth it?
In three things: save, variable operations reduce waste; stabilize, early pest and disease detection makes losses more controllable; and precise, irrigation goes from gut feeling to evidence. Cloud-based AI computing modules turn invisible into visible, experience into evidence. And at the end of the season, they tally input and output by zone. Farmers look at ledgers, not guesswork.
This is a very persuasive answer. To sum it up, AI turns invisible differences into visible maps, then turns maps into machine-executable routes, and finally turns results into smarter models for the next season.
Perfectly put. You can think of AI as a smartwatch for farmland. It doesn't do the farming for you, but it tells you when and where to take which action for the best return. And the cloud-based AI computing module is the computing heart of that watch.
Okay, that was looking from the sky. Now let's talk about working on the ground, the modern agriculture's powerhouse, drones. I've seen drones zipping low in orchards, spraying like paintbrushes that self-edge. I want to know, how is AI's role here different from satellites?
Satellites handle global checkups, drones handle local surgeries and close-up reconnaissance. On drones, the AI computing module is the onboard brain, doing three things: see fine details, spray precisely, fly steadily.
See fine details. How detailed can it see?
It's like taking a magnifying glass to the field. The drone's multispectral HD camera gets close to the leaf surface, and the onboard AI computing module runs detection and segmentation models to distinguish post-rain water spots versus lesions, crop rows versus weed strips, pinpointing treatment locations down to the row, down to the plant. Like taping masking tape before painting walls, cleaner boundaries.
That sounds really powerful. Next, spray precisely. I saw the nozzles switch between big mist and fine mist, even auto-raising or lowering.
This is variable rate operations plus terrain following. The onboard AI computing module fuses the prescription map with real-time sensing to calculate the flow rate and spray width for each flight path. Use heavier droplets in strong winds to reduce drift, raise the height for tall canopies, and lower it for short ones. Work with laser rangefinders and barometers to ensure even coverage on slope land. It's like cooking. You don't use the same one-size-fits-all settings for heat, oil, and seasonings. You adjust them as you go for each dish.
Great! David, you're really getting good at using metaphors.
Oh, really? Thanks for the compliment.
You are welcome. I also noticed it flies smoothly around tree canopies, like tailor-made for the trees.
Orchard scenes especially rely on path planning plus 3D mapping. The onboard AI computing module treats the canopy as a 3D object, uses 3D understanding to plan circular routes, avoiding spraying straight from above, which misses the inner parts. Like a barber moving around the head, making sure every angle is covered.
That's amazing. How do they keep efficiency up? I heard farmers say morning scan, afternoon map, evening execute.
That's low-altitude, fast cycles. Morning flight for sensing, Drone does pre-processing and initial judgment via onboard AI while flying. Noon, ground station and cloud synthesize prescription maps. Evening, execute variable spraying.
Um, what about safety and compliance? I don't want it flying over residential areas.
AI enforces electronic fences plus right-of-way rules. The onboard computing module treats no-fly zones, height restrictions, residential buffers as hard constraints during flight, adds safety distances near roads, water bodies. All actions are logged for supervision and review.
Sounds great. David, I want to know, how do drones and satellites work together? Don't let them do their own thing.
The key to collaboration is one data chain. Cloud-based AI computing modules circle where to focus. Drone's onboard computing module goes close-up verification plus execution. Drone sends back what was done, how it worked. Cloud time series model checks if the curve is back to normal. And sky gives direction, ground gives action. One finds differences, the other eliminates them.
That sounds like they're each doing what they're good at, complementing each other. David, last question. Do farmers have to learn a lot of complex stuff?
Nope, the complexity is in the system. Look at the map, generate prescription, execute. Onboard and cloud AI computing modules digitize experience, so farmers master a faster, steadier process. End of season, spread out the ledger, optimize thresholds for next season.
Putting these two applications together, I feel like AI makes farming more data-driven. See clearly from the sky, execute precisely on the ground, end up with plot-specific strategies that get smarter over time.
That's the goal. Let data truly land in the fields, turning into yield, quality, and peace of mind.
I'm sure the applications we just talked about will blow listeners' minds. Now let's switch to a closer-to-home topic, smart lawnmowers.
Yeah, let's do it.
I watched my neighbor's mowing robot create beautiful stripes on the lawn over the weekend, even avoiding the fountain and the kids' toys. What exactly is AI doing here?
Well, think of a smart lawnmower as a low-speed self-driving car working on the lawn. AI handles three things: see clearly, drive steadily, cut accurately. And the AI computing module inside the body is its on-site brain, fusing data from cameras, ultrasonic, radar, collision strips, IMU, wheel encoders in real time to make judgments.
How does it know what's grass and what's not? My flower pots, sprinklers, goal net are all on the lawn.
The computing module runs object detection and semantic segmentation models, tagging each frame: grass, edge bricks, flower pots, sprinklers, toys. At the same time, it combines ultrasonic and millimeter wave radar to measure distance and shape, avoiding misjudgments from only looking at images. Simply put, it's like your phone's camera recognizing scenes, but stricter. It has to see clearly in direct sunlight, shadows at night.
Got it. David, I noticed many new models don't need boundary wires anymore. How does that work?
It relies on vision plus odometry plus landmarks for boundary-free mapping.
What does it mean?
First, it uses visual recognition to see where's grass and where's not, drawing the lawn boundary. Then it counts steps as it moves, roughly knowing how far it's gone, how many turns it's made, to avoid getting lost. When it sees fixed objects like edge bricks, corners, tree roots, it uses them as landmarks to correct deviated routes. Combining this painted boundary and walked path into a lawn map stored in the machine, next time it can head straight to the point.
It's like a robot vacuum learning your room first, then cleaning in optimal routes.
Yeah, exactly.
Speaking of routes, I saw it can create stripes and avoid sprinklers, not just wandering randomly.
Yeah, that's path planning plus coverage control. AI generates stripe or checkerboard trajectories for the lawn, ensuring coverage and appearance. When it hits obstacles, it does local rerouting, like temporary detours in navigation. The challenge is skidding and slopes. It feels if it's tilting, going uphill or downhill, if the ground is slippery, if it's deviated, and adjust the trajectory to avoid uneven cuts.
Cutting precisely is key too, right? When the grass height is uneven, I want it to cut more where it's tall and less where it's short, rather than a one-size-fits-all cut.
That's variable mowing. The computing module estimates current grass height from camera and laser measurements, dynamically adjusting blade speed and cutting height. Slow, high torque in dense areas, fast light cuts in sparse areas. Slow down when wet to avoid tangling. Adjust height near edges to avoid balding edge vegetation. Think of it as a barber adjusting to the head shape as they go.
Excellent. And what about safety? Kids running into the lawn, pets lying in the sun. These scenes make me a bit worried.
Safety is a hard standard. The computing module sets highest priority detection and safety radii for people, pets, hands and feet, skirts, shoes, triggering lift blade to hover or retreat once they enter. It also monitors blade current and vibration, stopping the blade immediately for anomalies, stuck stones, tangled wire. At night or in shadows when it can't see clearly, it slows down or pauses until conditions improve.
That's amazing. To be honest, this is beyond what I expected. I also noticed it checks the weather, going back to the base early when rain is coming. Is that linked to the cloud?
It's cloud prediction plus on-site execution. The cloud gives suitable mowing windows based on weather forecasts and historical humidity curves, and the onboard computing module rearranges the day's tasks after receiving suggestions. If the rain sensor or camera detects wet ground, the on-site brain slows down or pauses to avoid clumping wet grass.
Great. My yard often has temporary activities, like setting up tables for a barbecue or the kids building a tent. I don't want to label everything in the app. Can it recognize and respect them on its own?
Yep. In relying on temporary landmarks plus no entry markers. AI recognizes newly appeared large objects as temporary obstacles, marking them as no entry zones on the map.
Great. Well done.
Next time it patrols and finds the object's gone, it automatically cancels the marker. You don't need to draw zones manually. It adjusts on its own.
Can you give me a lived-in loop picture so I feel it's really seeing, cutting, getting smarter?
Sure. Listen up. Say it first. Circles the lawn in the morning. Computing module quickly updating boundaries and obstacles, like a barber feeling the head shape first. Daytime, it follows the plan to create stripes, avoiding toys and sprinklers, cutting an extra pass in dense areas, light cuts in sparse ones. Evening, it archives. Coverage heat maps, blade load curves, anomaly points, fine-tuning routes and strategies the next day. A week later, you'll notice grass is more even, edges are neater, fewer obstacles hit, and the stripes look better.
We know AI is good at learning, so will it get smarter over time? Like learning my preferred stripe angle and weekly frequency.
Yeah, the computing module does preference learning on the machine, extracting preference templates from your manual adjustments. Angle, frequency, no entry times. New strategies first run in shadow mode to simulate, not directly changing actions, only going live when results meet standards to avoid breaking things.
Wow, that is definitely the power of AI. So, let me sum it up. In smart lawnmowers, the AI computing module is the on-site co-pilot on the lawn, linking seeing boundaries and obstacles, understanding grass status, planning routes, cutting safely, into a loop. It's not for show, but to cut every blade at the right place, the right time.
That summary could go straight into the product manual. When seeing, driving steady, cutting accurately are all done on-site and continuously self-optimized, the smart lawnmower isn't just automated, it's a thoughtful household partner.
From satellites looking at the ground, to drones executing precisely, to smart lawnmowers at the doorstep, AI's role is consistent. Turn invisible patterns into visible maps, turn maps into executable actions, turn action results into smarter next times.
You can also see that AI computing modules are like brain centers, good at both global understanding and on-site decisions, making agriculture more efficient, stable, precise, and housework more attuned to your preferences, safer, more hassle-free.
I think more importantly, AI isn't replacing people. It's helping them. Digitizing experience, making choices transparent, front-loading risks, letting us spend time and energy on more valuable things. AI isn't a distant black tech anymore. It's a reliable partner nearby.
Well said. Completely agree with you.
Thanks, David, for today's wonderful explanation. Listeners, hope you enjoyed today's content. See you next time.
Bye-bye.